Okay, in the last video, we were working with this problem here. We have the curve minus x squared plus 3x, straight line, y equals x. We found our points of intersection and determined this to be the region of interest, which we are rotating about the x-axis to create a three-dimensional figure, and we want to find the volume of it. Now, we have an introductory video concerning the disk technique, which is what we're using here. Hopefully you've looked at that video, because there we outline not only the disk technique, but kind of the strategy behind the technique. And in that video, in this kind of a situation where we have vertical strips here that we're rotating about the x-axis, that the volume integral is this, and that's true as far as it goes. But this was derived when we had just a single curve being bounded by the x-axis. Here we have a region of interest is between two different curves, so we had to modify our volume integral a little bit. It wasn't difficult. All we're saying is that in general, the volume integral is pi times the outer radius squared minus the inner radius squared. And we're going along on the x-axis here. As we're forming these vertical strips, they have a thickness of dx. So we're integrating with respect to dx. And all these vertical strips that we're making, we are forming them going from x equals 0 out here to the point of intersection where x equals 2. So the volume integral is pi. X goes from 0 to 2. The outer radius, that's just the y value of the outer curve, which is this. So that radius squared is this, minus the inner radius squared. And that's for the smaller curve, the y value of that smaller curve, which is just x. So there's our volume integral. And let's see. If we move along here, this right here, if we multiply this out, that would give us from here 9x squared minus 6x cubed plus x to the 4. And from here, that's just this, multiplying this out, 9x squared minus 6x cubed plus x to the 4th, and we're subtracting off x squared, so our whole expression here for everything will be 8x squared. So that's what this above value is, and we want to integrate that. So let's see. Integrating this with respect to dx, 8x squared, that would be 1/3 x cubed, so that would be 8/3 times x cubed. This is minus 6x cubed, so that would be minus 6/4 x to the 4th, integrating x cubed. We raise to the power 4 and we divide by 4, plus x to the 4th. We integrate that, that'll be 1/5 x to the 5th. And this gets multiplied by pi, and x goes from 0 to 2. So that's it. Put your value for x in. Well, we have 0 here, so put 2 in. Crunch those numbers out. And I think you see the volume comes out to be equal to 56 divided by 15 times pi. So that's our volume there. Okay, and that was now, again, taking this figure here and rotating it about the x-axis. Now, let's consider a little bit of a different situation. Say that we're not going to rotate it about the x-axis, but instead we're going to rotate it about this line here, y equals -4. And then what our volume integral is, volume integral equals pi, the integral of the outer radius squared minus the inner radius squared dx. Well, here then, what we can think of is we have these vertical strips that we made before, but now we're not rotating with the x-axis, we're rotating about this horizontal line. So we have to extend them like this. So our new outer radius that's going to be this distance that we always had, plus we have to tack on an extra 4 units. So the new radius is going to be minus x squared plus 3x plus 4. So we have minus x squared plus 3x plus 4. And the new inner radius, that's going to be this distance, which is x plus 4. And we're still adding up all these vertical shells, starting at x equals 0, going to x equal to 2. That doesn't change. So here then, the new volume integral is going to be pi, the integral from 0 to 2 of this minus x squared plus 3x plus 4 quantity squared minus x plus 4 squared. Times dx, and that would be our new volume integral. Now we are rotating about the line y equals -4. Okay. All we had to do is think about, when we have this new axis of rotation, how does that affect the values of the outer radius and the inner radius? We just modify it accordingly. It's not a big deal. We just got to kind of think about what we're doing. Now, imagine that we have the same deal here. Let's see. We can make some room. We're going to have to extend our y-axis upward. And we don't need this anymore. Okay, here's our basic graph. Now we're going like this. We can draw it reasonably straight. And here we have the line y equals 4. Our new axis of rotation. So now we're going to be rotating not about the x-axis, but about this horizontal line. And we want to know what is the new outer radius and what is the new inner radius. Well, first of all, the radius, that is the distance of our volume strip here, from the new axis of rotation. See, here we had it like this, and we said, well, the distance is just the y value of the big curve and the y value of the small curve. That was the distance from the x-axis, and originally that was our axis of rotation, but no more. So now we want to know what is the distance of this from this horizontal line. Well, this total distance is 4. well, starting from the x-axis up to here, this distance from the x-axis up to here is this. So our new outer radius is going to be is the distance between here and here, which is going to be 4 minus this. So we're going to have 4 minus x squared plus 3x. Hold on, did we write this? Yes, we did, except we have minus x squared in here. So it's 4 minus this distance here gives us this distance here, which is what we're interested in. So it's going to be 4 minus this distance, minus x squared plus 3x. And for the new inner radius, it's going to be 4 minus this distance here. So it's going to be 4 minus x. So now, let's see, here we have 4 minus negative x squared plus 3. That will be 4 plus x squared minus 3x. So our new volume integral then is going to be pi, the integral, and we're still adding up these vertical strips from x equals 0 to x equals 2. That doesn't change. And now we're going to have our new outer radius, this, x squared minus 3x plus 4, this quantity squared minus the inner radius, the new inner radius, that's 4 minus x squared dx. And that would be our new volume integral. And again, just to try to clarify this, the radius here with our new axis of rotation is the distance of from the horizontal line down here to the curve. That's what we want, is that distance there. And it's equal to this distance, subtract that distance away. And that's what we said right here. That's our new outer radius. Our new inner radius is this distance minus the distance of this line right here. And that vertical distance of the line is just x. So that's just 4 minus x for our new inner radius, giving us our new volume integral. And now then what we're doing is rotating this about that horizontal line. So that's it for this video. Hope it was worthwhile. And come back and join us for some more videos, and we'll try to solve some more problems.